Right, so in the last 2 centuries, since the metric system was devised, we've learned to make measurements from really, really massively small things, like nuclear particles, to really, really big things like the distances to far galaxies. And because the metric system is all in decimal form, it makes it pretty straightforward to do this. And they vary very consistently from one measurement to the next. So let's start by looking at the base unit. Whatever the unit is, like you might be talking about distance, in which case the unit would be the meter. You might be talking about time, in which case the unit would be the second. Okay, so whatever the base unit is, we start there, and then we can either go up or down from there. Now, mostly we do it in factors of 1,000. So if we start from the base unit and we go up by 1,000, so 1,000 times larger, we have the kilo. All right, K for kilo. And we know this already because, how far is it? Oh, it's 2 meters away. So we go from the meters. Oh, but how far is it really? If it's lots of meters, well, it might be 2 kilometers, right? Kilo meaning 1,000. So let's say 207 kilometers is the same as saying 207,000 meters, right? So we use that prefix in front of the unit, right? Just to mean kilo, right? How much do you weigh? Oh, 58 kilograms. Well, that's 58,000 grams, right? So the kilo just means 1,000 because we've gone up times 1,000. Let's go up again. 1,000 times more than kilo. Well, that puts us at mega. Now, the easiest way I think of to remember these few going up in terms of computers, because back in the really early days, we had kilobytes, and then we got better, we had megabytes, and then 1,000 times larger than a megabyte was a gigabyte. And these days, your hard drive on your computer is probably a couple of terabytes, because that's another 1,000 times bigger. Okay, so nearly looks closed. There we go. And then, of course, we can keep going bigger and bigger. This is actually getting a bit messy. Right, so we'll start from a unit. All right, so we'll go up by 1,000. Just redrawing this very quickly, we can also come down by dividing by 1,000. So if we start from our unit, we go up, we have kilo, and then we said mega, giga, tera. We can still go up further than that. We can go peta, as in P-E-T-A, not P-E-T-E-R, the boy's name. So peta, we can go up to exa, we can go to, running out of room again. That's a capital Z, zeta, and then iota. So if we were talking about lots and lots and lots and lots of something, we might use iota. Let's talk about the mass of the Earth. The mass of the Earth is about 5,972 iota grams. Okay, so that's how we use this in the metric system. We use the prefixes. Okay, so we don't always do this, because if you said to someone, hey, what's the mass of the Earth? They probably wouldn't say 5,972 yotagrams. No, of course not. They would say 5.972 by 10 to the 24 kilograms, wouldn't they? Everyone knows that, right? So they'd say 5.972 by 10 to the 24 kilograms. Now, this is because some units we just like to use more. Kilogram is very common. We know it. You say, hey, a kilogram, everyone knows what it is. You say, 100 kilograms, yeah, it's fairly heavy. You say 2,000 kilograms, it's really heavy. You say 5.972 by 10 to the 24 kilograms. They think, oh, you're talking about the mass of the Earth. Yeah. Okay, so we still use other units. We can convert pretty easily, but in terms of the prefixes, these are them. So we've got the kilo, mega, giga, tera, peta, exa, zeta, and the iota. Now, these are all in terms of 1,000, right? 1,000 times bigger. Before we have the kilo, in fact, the first couple, actually, let's go down 1,000 times first. And so we're going to drop down to the milli. Milli is 1,000 times smaller. That's why there are 1,000 millimeters in 1 meter, right? It's a thousandth of a meter. And then smaller than that, we can go micro. Oh, wait, there we go, we're back. We can go micro, looks like a U with a tail at the front. So micro is divided by 1,000 again, so another 1,000 times smaller. So micro means 1 millionth because it's 1,000 times smaller and then 1,000 times smaller again. So it's actually divided by 1,000,000. If you divide by another 1,000, so all up we're dividing by 1,000,000,000 now. We're at the nano. Okay, so when you think about nanoparticles, they're a big thing these days. Well, they're really, really small. Something like the wavelength of light might be, blue light might be 450 or so nanometers. Well, that's 450 billionths of a meter for the wavelength of the blue light. But just like we went bigger, 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 we can go smaller, smaller, smaller. So 1,000 times smaller than nano is the pico. And then we have the femto, and we've got a few more. We can go smaller still to the atto, and then we have the zepto. Now, capital Z is really, really big, that's zeta, but a lowercase z is really, really small, that's zepto. And then again, capital Y, really massively large, was iota, but a lowercase y is really massively small, that's yocto. Right, so these are prefixes. In fact, what I should have really done was write them in. So we can go kilo, and then we have mega. When we're writing the prefixes, we don't have to start with a capital, but the symbol of the unit, they actually do get a capital letter. What have we got here? Peta, E is for X, capital Z, the big version of the Z is zeta. And running out of room once again, we have iota. This is massive, really, really big. And coming down, 1,000 times smaller than the unit, we have milli, micro. Think a microscope. It's really, really small, isn't it? The things that you look at with a microscope. And then we've got nanoparticles because that's even smaller. And smaller than nano is pico. Smaller than pico, femto. Now I'm going to duck out to the right because I really can't fit all these. A is for atto, lowercase z, the really little version of the z is zepto. And then we have yocto. Right, there we go. So there are our prefixes in the metric system. And like I say, all 1,000 times different from the one above or below. Now, I also mentioned around the unit, we've actually got some others. We don't have to go in terms of 1,000 because we all know centimeters, right? Well, centi is 100, isn't it? So just above millimeter, we actually have centimeter, right? So above milli, we have centi. Now, that's actually divided by 100 to get that. Hence, there are 100 centimeters in 1 meter. We could actually go deci as well. Okay, so that's take from your unit and then just divide it by 10 for deci. Now we can go in similar fashion a little bit bigger than the unit. If we times the unit by 10, then we're at deca with a K. And then one more times 10 and we're at hecto. So sometimes we use these, like centi we use all the time, centimeters. Hecto, you may have seen if you've watched the news and the weather, and the isobars on the weather maps given in hectopascals, the pressure. Deci, if you were in the UK, you might be talking about decimeters cubed for a litre. We say a litre, but 1 litre, well, you could, instead of litre, you could talk about 1 decimeter cubed, 1 cubic decimeter. So there we go. There are the prefixes that we use in the metric system. A little bit messy, a little bit scribbled and scrawled, but there they are anyway.